Hi math students, it's Mrs. Marcellus for COT. Today we're going to learn about function rules. Today's learning objective, students will extend and describe arithmetic and geometric sequences using algebraic expressions. Ooh, sounds like fun, doesn't it, for COT? A sequence is an ordered list of numbers. A term is each number in a sequence. An arithmetic sequence is found by adding or subtracting the same number each term. For example, if we have the sequence 1, 5, 9, 13, 17, we can see that 4 is added each term to get the next number. A geometric sequence is found by multiplying or dividing the same number each term. Here we have the sequence 2, 6, 18, 54, and so on, and we can see that we multiply times 3 to get from term to term. How about we give some a try? In our first problem, we're going to describe the relationship and find the next two terms in this sequence. Then we will determine if the sequence is arithmetic or geometric. In order to describe the relationship, we have to figure out what is happening from term to term. We start with 0 and then the next term is 16. Since the value is increasing, we would look for addition or multiplication. We know we can't multiply 0 times anything and get a bigger value, so the best bet here is addition. To get from 0 to 16, that means we will add 16. To get from 16 to 32, we'll add 16, and so on. So we can see that the relationship is plus 16 each time. In order to get the next two terms, we will have to add 16. 16 plus 64 is 80, and 80 plus 16 is 96. Since we are adding the same value each time, we know that this is an arithmetic sequence. Let's take a look at this sequence, describe the relationship, and find the next two terms. Then we'll determine if it's arithmetic or geometric. To get from 2 to 10, we would either add 8 or multiply times 5. We'll have to continue checking out further terms to see which one holds true. 10 plus 8 is 18 and not 50, so it doesn't look likely that we're adding 8 each time. However, 10 times 5 is 50. It looks like our relationship is going to be times 5. So to find the next two terms, we will multiply by 5. 250 times 5 gives us 1,250. That multiplied by 5 gives us 6,250. Since we are multiplying by the same value each time, this is an example of a geometric sequence. In this sequence, our values are getting smaller, so we'll either be subtracting or dividing. It doesn't look like we can easily divide and get from 45 and 5/10 to 43 and 2/10, but we can get there by subtracting 2 and 3/10. And this pattern carries on throughout the sequence, so the relationship is to subtract 2 and 3/10. In order to find the next two values, we'll continue doing that. 38 and 6/10 minus 2 and 3/10 is equal to 36 and 3/10. When we subtract 2 and 3/10 again, we end up with 34. Since we are subtracting the same value every time, this is an example of an arithmetic sequence. Let's take a look at a table to determine a function rule, and then we will find the value of the 15th term. When we're looking at these tables, the position is going to be the x, or input value, and the value of the term is going to be the y, or output value. When we read these tables, we go from the position to the value of the term, or the top to the bottom. So if we put in 2, we get out 12. We can either add 10 or we can multiply times 6. We'll look at 3 to 18 and we can see that that is times 6, but it's not add 10, and 4 to 24 is times 6, and 5 to 30 is times 6. It's looking like our rule is going to be n times 6. In order to write that algebraically, we would write the rule is 6n. In order to find the value of the 15th term, we'll plug 15 into the rule. That would mean we'll have 6 times 15, and 6 times 15 equals 90. Let's find the rule for this table and find the value of the 15th term. So to get from 5 to 10, we're either going to multiply times 2 or add 5. To get from 6 to 11, we don't multiply by 2, but we do add 5. To get from 7 to 12, we will add 5, and from 8 to 13, we will add 5. So our rule is going to be the number plus 5. To find the value of the 15th term, we will plug 15 in for n. 15 plus 5 gives us 20. Let's find a function rule for this table. To get from 0 to 2, our only option is to add 2. That would mean we would have to add 1 plus 2 and get 3, but we can see that we get 5 as an output instead. So adding something's not going to work either. When you have a table like this and you are unable to either add, subtract, multiply, or divide by the same value over and over again, that tells you that you're going to have a two-part rule. You are going to have the number times something and then plus or minus a constant. To determine what that coefficient will be, or what we will be multiplying n times, we need to analyze the outputs. To get from 2 to 5, and 5 to 8, and 8 to 11 is plus 3 each time. This will be our coefficient. The first part of our rule is going to be 3 times n. Now that we have that piece of information, we can figure out the rest. 3 times 0 is 0, and in order to get to 2, we will add 2. It looks like this is going to be our rule, but we want to double check with some other values to make sure it holds true. 3 times 1 is 3 plus 2 is 5, so that checks out. 2 times 3 is 6 plus 2 is 8, check, check. 3 times 3 is 9 plus 2 is 11, so triple check. Now that we know the rule, we can find the value of the 15th term. In order to do that, we'll multiply 3 times 15, and that will give us 45. Then we will add 2 more, which gives us 47. The value of the 15th term is 47. The table shows the amount it costs for one person to see the special big cat exhibits at the zoo. What is the rule to find the amount it costs to see X special exhibits? I'm guessing that we're probably going to have some type of admission price plus a cost per exhibit, but let's look at our table to find out. To get from 1 to 12, our input to our output, we will either add 11 or multiply times 12. If we look at 2 and add 11, we get 13. So that doesn't look like it's going to work, and 2 times 12 is 24. This is our big clue that we're going to have a two-part rule. We're going to have something multiplied times x plus a constant value. In order to find out that something multiplied times x, we will analyze our outputs. To get from 12 to 14, and from 14 to 16, and 16 to 18, we are adding 2 each time. Therefore, the first part of our rule is going to be 2 times x. Now that we know that part of the rule, we can figure out the rest. 1 times 2 is 2, plus 10 is 12. So it looks like we're going to add 10. Of course, we need to check that out. 2 times 2 is 4, plus 10 is 14. 3 times 2 is 6, plus 10 is 16. So it looks like our rule is correct. Basically, this tells us that there was a $10 admission to the zoo, and it's $2 for each extra special big cat exhibit a person wants to see. Verkat says he'd really like to go to the zoo to check out those special big cat exhibits, so I think that's what we're going to do. This concludes our current lesson, so bye for now, math students.